Hi folks, welcome to this video on sneaky stuff in indefinite integrals. So in the last video we looked at what we'd do if we had to integrate something of the form f of ax plus b, but you may end up with a binomial that's not of that form. So the problem in this case over here is that it is not ax plus b. So you can try doing your tricks. You can try just bringing the power up by 1, and maybe putting 1 over 2 out front, and then getting 1/6 2x squared minus x all cubed. And then you're going to check. Okay, so the 3 will come down, so 1/6 and 3, 2x squared minus x all squared. And then the chain rule comes in. And here's where it all looks pretty bad. The chain rule, if you don't just have ax plus b, the chain rule creates a mess. You're never going to get back to this elegant expression over here. So instead, we have to go for something that's maybe a little simpler in a way. And I think there's a good chance that you can already guess what that is. What we could do is we could expand first. So I've got to figure out what 2x squared minus x times itself is. And that would be 4x to the 4 minus 4x to the power of 3 plus x squared. Once it's in this form, it's pretty easy to anti-differentiate or to find the indefinite integral. Power goes up by 1, flip of the new power goes in front. Power goes up by 1, flip of the new power goes in front. Power goes up by 1, flip of the new power goes in front, plus c. 4/5 x to the power of 5 minus x to the 4 plus 1/3 x to the 3 plus c. You can check this, and I think you should, by differentiating. But maybe we're getting to the point where that doesn't need to be explicit every time. Maybe you can do that differentiation in your head. Just make sure, it gets us back at least to this stage where we sort of started. That brings us to what I'm going to call an optional side quest. I'm not sure that you'd actually run into a whole lot of this in the IB course. But if you have a squared trig function like this, so the problem is squared trig. Okay. It's not, so that means that this is cosine of x all squared. Okay, so we could try our regular stuff and say, it's going to be 1/2 cosine of x, 1 over 3 cosine of x to the 3 plus c. But as soon as you start differentiating that, you can see that the chain rule is going to make a mess out of this. There's going to be no easy way to deal with it. But there is a little trick. We know this from the formula booklet. Cos 2x has a bunch of definitions. One of them is this, 2 cos squared x minus 1. And it turns out you can rearrange any of these identities. So really 2 cos squared x is equal to cos 2x plus 1. Or if you divide both sides by 2 or multiply by half, you get this. 1/2 cos 2x plus 1/2 is equivalent to cos squared. And while the thing on the left might look less elegant, it's actually easier to integrate. So the trick is use trig identities. In this case, double angle identity. There'd be another one that you could use if you had sine squared. It would still be a cos 2x identity. And so if I write it in this form, 1/2 cos 2x plus 1/2, that's what we're integrating. Okay, I'll write my wheel of trig over here. And I know I go counterclockwise to anti-differentiate. The 1/2 stays. Cos x anti-differentiates to sine 2x. If you're paying real close attention here, that 2x is going to cause us to have another half here. Or you could botch it and then just fix it later. 1/2 is a constant, so it becomes 1/2 x, and then plus c. In other words, we'd get 1/4 sine 2x plus a half x plus c. Now, we probably want to check this. So it would give us 1/4 cos 2x times 2 plus a half. And you can see these are going to divide out a little bit. You'll get a half cos 2x plus a half, which at least is the version of the integral that we looked at over here. So things are looking good here. We've got a way around this little trick. Again, I'm not sure if this will come up in the IBAA course, in the SL course, but it's something that you might see eventually. Being able to manipulate trig functions is one of the wonderful things about trig functions. They can be presented in a lot of different forms. The practice here is the same stuff from before, so there'll be nothing explicitly on these two little tricks, but it's nice to be aware of them. I hope that this has been helpful. Good luck with the material, folks, and take care.